Okay, let me grab this graph. Let's say this is your plane. So let's say this is our point. So because our plane is given, so it means you have a point here. It's passing from this point. Let's say this is x1. So a1, b1, c1. And this one is p sub 0. Or x sub 0, let's say. X sub 0. So this one is x sub 0, y sub 0, z sub 0. So we are trying to find this length. This is the point, and we are trying to find this length, the perpendicular one. So we have this one here. So this is the perpendicular. Okay, this is so let's say the plane, let a times x, b times y, plus c times z, plus d equals 0, a plane, and x1, a point, which is not on the plane. So we are trying to find this one, this u. So let me change this one. Let me put here. So now x1, x sub 0 will be parallel to n. N is the unit, or may not be unit, but normal vector. N is normal vector of plane. So we know that this normal vector because n will be A, B, C. So x sub x1, x sub 0 will be this one. x1 A0 origin mean minus origin x sub 0. because this x1 x sub 0 is parallel to the n, if you multiply this one by x1 x sub 0, let's say n, so it will be this form. Now x1 0, it means a1 b1 c1 times abc plus, or minus here, so a times x sub 0, b times y sub 0. Okay, let me write same for the other part. So first you have this one, x sub 0, y sub 0, z sub 0, and a, b, c. So you have this one, a times a1, b times b1, and c times c1, minus a times x sub 0 plus b times y sub 0 plus c times z sub 0. So if you look at this part is D, because the point satisfies the equation. So this will be B, D. Including this one. So you have this one, a times a1, b times b1, plus c times c1 plus d. So look at this side. Because this is a parallel, you have this one, x sub 1, x sub 0. So n, the length, the angle between them, cosine of theta. So this, because they are parallel, it means this one will be negative or positive 1. So either will be 0 or will be pi. Okay? So that's why we have this one, x 1 x sub 0, this is u, the distance, you have negative or positive. So the top, which is this one, so a times a1, b times b1, c times c1 plus d, over, so this one, n, a square, b square, plus c square. So negative or positive, what does it tell us? It tells if the point is the positive side of the plane, it will be positive. If the negative side of the plane, it will be negative. So how to determine the side? So if you, in the beginning, if you decide which part is positive, then you can change to this position. Okay, let me give one example. What does it mean to this negative positive? So consider this example. Find the positions of the points. So 1, 1, 1, and 2, negative 2, 4, with respect to the plane x minus y plus 2 times z minus 7 equals 0. So are they on the same side of the plane or on opposite sides? Okay, first let me check the distance. So distance from 1, 1, 1 to the plane x minus y plus 2 times z minus 7. So let's say u1. So you have this one. If you put this value here, 1 minus 1 plus 2 minus 7 over 1 plus 1 plus 4 square root. So you have this one. So negative 5 over 6. So this is the opposite side. Distance from let's say 2, negative 2, 4. So this one. So in this case u2 will be 2 plus 2 plus 8 minus 7 over square root 6. So you see you have this one. 5 over square root 6. So they are on the opposite sides. Of course, you need to put this one here, right? So because we are mentioning about the distance, it will be absolute value of this number, okay? Because we are mentioning about the distance. So it will be good idea to put here. Okay, so now consider this one. The angle between the plane and the line. Okay, now let a times x plus b times y plus c times z plus d equals 0 be a plane, and x minus x sub 0 over p, y minus y sub 0 over q, z minus z sub 0 over r, a line. So we have this one, there is a plane, this is our plane, and this is line. So we are so this is our theta. We are looking this one. Of course, we have a normal here. This is normal. So let's say this is n. This is L. So because normal is perpendicular here, this part will be pi over 2 minus theta. So the question reduced to this one, the angle between plane and the line reduces to between n and d. D is the direction vector. So now we have this one. So cosine of theta, cosine of pi over 2 minus theta, because this angle is this one. So you have n times d over the length of these two items. So d will be this one, right? D p q r. So you have this one, a times p, b times q, c times r over a square, b square and c square, and p square, q square and r square. So this is the angle. Of course, we know that this one, sine of theta will be, so you have this one. So this is this one. The angle between plane and the line. Okay, so let me give one example for this formula, just application. Find the angle between the line x minus 2 or 1 equals y plus 2 or 1 and z equals 2, and the plane is x plus z plus 7 equals 0. So you see you have d, the direction vector of the line, 1, 1, 0, and n is 1, 0, 1. So sine of theta will be, if you multiply this one, 1, this one only 1, over, this one is square root 2, this one is square root 2, so you have 1 over 2. So theta will be pi over 6, 30 degrees. Also, we can compare these n and l. If the inner product n and l is 0, it means they are parallel to each other. So one will be this form, one will be this form, right? So we can write immediately this one. Okay, let me write here. So L and the plane P is parallel if and only if A times P plus B times Q plus C times R is 0. And L and the plane P is perpendicular if and only if their normal vector and the direction vector will be parallel to each other. You already know this information because we, in our previous lectures we saw the positions of the line and with the plane. So we know how to find their positions relative to each other. Now I will give the two planes. So positions of two planes relative to each other, and the angle between them. So let's say given two planes, so let's say A1 X, B1 Y, C1 Z, D1 equals 0, and A2 times X, B2 times Y, C2 times Z plus D2 equals 0. So what are the positions? So the first one, they may intersect each other. So other one will be in this form. Okay, they may intersect each other, or they may be parallel to each other, like this one, or they may be the same plane. So actually they are not different plane, but same plane. So let's say the other one. So they are same plane. There is no. So these cases, so they may intersect each other. We know how to find the intersection line. So I gave you 3 methods how to find the intersection line, and then we can check their normal vectors relative to each other. So first, the angle. Let me write the angle, or maybe I should. This one it should be more easy to see the angle. Okay, let me draw in this form. So you have this one, and then you have this one. Okay, so this is the line. They intersect each other. So the angle between them will be the angle between these 2 planes will be the angle between their normal vectors. Okay, so that's why I can write this one. Cosine of theta equals n1 inner product n2 over their length n1 and n2. So here n1 is this one, a1, b1, c1, n2 is this one, a2, b2 and c2. So if you multiply, you have this one, a1 times a2, b1 times b2 plus c1 times c2 over, so this one, a1 square, b1 square, c1 square and a2 square, b2 square and c2 square. So this is the angle. Because we find the angle, now if they are orthogonal to each other, it means the angle will be pi over 2 or 3 times pi over 2, right, like this one. And if they are parallel, it means their normal vectors will be parallel to each other. So we have this one. If so let's say this one P1, okay, P1, this one P2. So P1 and P2 are parallel if and only if A1 over A2 equals B1 over B2 equals C1 over C2. Okay. They are orthogonal. Perpendicular, I mean. So in this case, you have this one. A1 times A2, B1 times B2, and C1 times C2 will be 0. So this is the perpendicular case. And the last one, P1 and P2 are same plane. So in this case, you have this one. Their normal will be parallel. And their distance from the origin, this vector, this line segment, will be parallel. Okay, let me consider this example. Check the positions of the planes x minus y plus 5 equals 0 and x plus z minus 3 equals 0 if they intersect each other, find the intersection line and the angle between them. So when you look at this problem, it will be suitable to find the angle. Now, if you find the angle is pi over 2, it means they intersect each other perpendicularly, so they have an intersection point, and the angle will be clear. Otherwise, you can find the angle. Also, you figure out there is an intersection between them. Then you try to find the intersection line. So there is no need to in the beginning to check the intersection line. So we need to find the angle, and then we decide to find the intersection line or not. So first, let me the normal vector. The first one is this one, 1, -1, 0, right? The second one and 2, 1, 0, 1. So the cosine of theta between them, cosine of theta will be 1 over square root 2 and square root 2. So you have 1 over 2. So it means theta is pi over 3. So they intersect each other, but not perpendicularly each other. Okay? So now the question, find the intersection line, this is all problem. We already know how to find this intersection line. So either you can find the 2 points, or you can choose together, or you can find the normal vector. So I will choose to solve these together. So x minus y equals negative 5, x plus z equals 3. So let me choose one parameter. Let's say y is t. So y is t, x becomes negative 5 plus t. So then z becomes, z equals 3 minus x. So z equals 3 minus 5 plus t. So z becomes 8 minus t. So the intersection line will be x plus 5 over 1 equals y over 1 and z minus 8 over negative 1. So this is intersection line. Okay, we continue to properties of the plane and the lines. So now bisector of two planes. So what does it mean? You have two planes. Okay, let me this is much better. Okay, now you have another one. Let's say here. Okay, so now if you have point here, it means the distance from here to here and here to the other plane will be same, because this is the definition of the bisector, right? So let's say this P1, this is P2, and this P3. So P3 is the bisector plane of P1 and P2. So let's say P1 is this one, A1 times X, B1 times Y, C1 times Z plus D1 equals 0. And P2, A2 times X, B2 times Y, C2 times Z plus D2 equals 0. Now, any point on P3, any point has same distance to P1 and P2, but side will be different, right? So we have this one. Let's say let this point, let's say let's say x equals xy and z be a point on P3, the bisector. So then you have this one, the distance. So A1 times x, B1 times y, C1 times z plus D1 over A1 square, B1 square, C1 square equals plus or negative A2 times x, B2 times y, C2 times z plus D2 over A square, B square, C2 square. So the locus of these, because this x is arbitrary point, the locus of this point satisfying the above equation gives the bisector plane. Okay. Okay, so I'll consider this example now. find the point on the x-axis such that distance to the plane, so 2 times x minus y plus 2 times z plus 5 equals 0, and x plus 2 times y 2 times z is plus minus 4 equals 0 are equal. So we can ask this question as this one. So if the bisector plane of the two, let's say these two planes, is passing from the x-axis, then find a point on this bisector plane. Yeah, that's the question. So we can ask in this form, okay? Because the idea is same. So because a point on x-axis will be x sub 0, 0, 0, right? So now we have this one. Okay, the first one, 2 times x sub 0 plus 5 over 4 plus 1 plus 4 equals negative or positive. So x sub 0 minus 4 over this one, 1 plus 4 plus 4. So actually you have this one, right? 2 times x sub 0 plus 5 equals minus or negative x sub 0 minus 4. So you have this one, x sub 0 plus 5 equals x sub 0 minus 4. So x sub 0 will be negative 9. Or this one, or you have this one, 2 times x sub 0 plus 5 equals negative x sub 0 plus 4. So you have 3 times x sub 0 equals negative 1. So x sub 0 will be negative 1 over 3. So you have 2 points actually. These points are negative 9, 0, 0 or negative 1 over 3, 0, 0. Okay, now consider this problem, family of planes. So let's say you have two planes. Let A1 times x plus B1 times y plus C times z plus D1 and equals 0, and A2 times x, B2 times y, C2 times z plus D2 equals 0. Be two planes. Now, for non-zero real numbers, let's say mu and lambda, and let's say sigma, we can write A times x plus B times y, C times z plus D1 plus, these, let's say mu, these, let's say sigma, A2 times x, B2 times y, C2 times z plus D2 equals 0. Or you can write this one, sigma over mu, because it is not 0. Let's say lambda also is not 0. Then you can write A times x plus B times y plus C times z plus D1 plus lambda times now 2 times x, B2 times y, C2 times z plus D2 equals 0. Or you can write this one, A1 plus lambda 2 times A2 x, B1 plus lambda 2 B2 y, and C1 plus lambda times C2 z plus D1 lambda times D2 equals 0. So this equation shows that the planes passing from these planes, so with respect to lambda. So for each lambda you have another plane. So that's why, and therefore this equation gives the family of planes. So in the beginning, if two planes are parallel, so what does it mean? It means you have this one. Parallel. So you have A1 over A2 will be B1 over B2 equals C1 over C2. But we know from this we can say for lambda is not 0. Okay, so you have this one, A1 plus lambda times A2 over A2 equals B1 plus lambda times B2 over B2, and C1 plus lambda times C2 over C2 will be same. So if two planes are parallel, then let's say these Q, the plane Q will be parallel to them. So if in the beginning they are parallel planes, then you may, if you find the family respect to of course lambda, then these last plane also will be parallel to the beginning planes. Actually, we used this technique to find the plane, but now we will use this family idea, like this one. Okay. Find the plane passing from the point 1, -1, 1, and the intersection of the planes two times x plus y minus z plus 1 equals 0, and 2 times y 5 times z minus 4 equals 0. Okay, first the family determined by the planes. Which planes? 2 times x y minus z plus 1 equals 0, and 2 times 4 plus 5 times z minus 4 equals 0 is this one. 2 times x plus y minus z plus 1 plus lambda times 2 times y plus 5 times z minus 4 equals 0. So this family passing from the point 1, -1, 1. So you have this one. Two minus 1 plus no. Yeah, this minus 2 minus 1 minus 1 plus 1 plus lambda times 2 plus 5 minus 4 equals 0. So you have this one 1 plus 1 3 times lambda equals 0. So lambda becomes -1 over 3. So if you put this lambda here, you have 2 times x plus y minus z plus 1 plus negative 1 over 3 times, let me change me, 2 times y plus 5 times z minus 4 equals 0. So you have this one, 2 times minus 2 times y. So you have y. Oh no. Okay, let me. So you have this one. Okay, now we have 6 times y, 6 times x, 6 times x plus 3 times y minus 3 times z plus 3 minus 2 times y, 5 times z plus 4 equals 0. So you have 6 times x plus y negative 8 times z plus 7 equals 0. Okay.